You study for physics, you feel prepared, you walk into the exam thinking, okay, I got this. And then it happens. You read the first problem and your mind stalls. Not halfway through, not at the math, right at the start. Something breaks. I'm the physics sensei, PhD in physics, black belt in karate, and 30 years teaching college students just like you. My job is simple to train you the right way. So physics becomes something you can do, not something that falls apart under pressure. And today I'm going to show you why exams expose your weaknesses and how to fix the system behind them. If nothing changes, you already know what happens. More panic on test day, more second guessing, more points lost by mistakes you should have known. Exams don't forgive weak systems, they expose them. And the longer you ignore that, the more fragile your performance becomes. Here's the truth most students never hear: physics exams don't test knowledge, they test performance under uncertainty. And most students are training for understanding, not for execution. That is why everything breaks on exams. So in this video, I'm going to walk you through 5 execution breakdowns that explain exactly why exams feel brutal and how to fix them. Let's start with the first moment exams fall apart. Before math, before formulas, before anything else. The freeze on the first line. Here's what's actually happening. When you read the first line, your brain tries to solve immediately. You scan for numbers, you hunt for formulas, you ask, which equation is this? That's the mistake. Physics problems don't start with equations, they start with situations. And when you skip that step, your brain stalls. That freeze is not confusion, it's a misinstructor. Your brain is waiting for one thing you never give it. What is happening here physically? Until that question is answered, nothing else works. So the system locks up. Homework feels easier because you just saw a similar problem. You know which chapter you're in, and you expect the formula. On exams, all of that disappears. Now, we have to decide what kind of situation is this? What system am I modeling? What matters and what doesn't? If you never train that skill, the exam exposes it immediately. That's why the freeze happens on the first line. The first line of a physics problem is not information, it's a description of reality. If you treat it like a formula trigger, you stall. If you treat it like a situation to interpret, you move forward. That difference decides everything. Strong students pause. They don't rush to solve. They ask, what is happening here in this particular problem? What objects are involved in this situation? What is changing here? So I need to understand what's happening. They build the picture first, and the equations comes after that. If you freeze on the first line, stop blaming pressure, stop blaming the math. You're not failing physics, you're just skipping the setup. So fix how you begin, and the rest of the problem starts to cooperate. Now you might say, but I understood this in class. And you're probably right, but understanding is not the same thing as performing. Here's what's actually happening. Understanding feels good, but understanding is passive. You recognize the ideas, you agree with the explanations, and you say, yeah, that makes sense. But none of that is performance. Physics on an exam is not recognition, it's execution. You have to decide what applies here, what doesn't, what matters first, and if you never train those decisions, your understanding collapses. That is why class feels easy, and exams feels brutal. In class, the path is shown to you. The steps are guided. The thinking is done out loud. On an exam, you are alone with the situation. No hints, no structure, and if you only practice understanding, you weren't training performance. Understanding answers the question, do I recognize this? Performance answers a different question. Can I act when nothing is obvious? Those are not the same skill. This is why students say, I knew this stuff, but can't start the problem. They train familiarity, not execution. Strong students do something different. They practice deciding, they practice choosing an approach, they practice starting without guidance, they train the uncomfortable part. Understanding feels safe, performance feels uncertain, but physics lives in uncertainty. If you never train there, exams expose it immediately. If your understanding disappears under pressure, stop blaming stress. Stop blaming memory. You didn't fail because you didn't understand. You failed because you didn't train performance. So you respond the only way you know how. You do more problems, more homework, more hours, and still nothing changes. Here's what's actually happening. You're doing problems, but you're not fixing mistakes. You repeat the same thinking. You repeat the same step errors. You repeat the same guesses. And practice without correction doesn't build skill. It reinforces habits. Most students believe if I do enough problems, I will get better. That's not how learning works. If you practice the wrong move, you don't get stronger. You get consistent and being wrong. That is why homework feels productive. You finish pages, you check boxes, you feel busy. But busy is not the same as improving. Improvement only happens when you know what went wrong, why it went wrong, and what to change next time. On exams, repetition gets exposed. The problem looks different. The numbers change. The surface shifts. And suddenly, your practice doesn't transfer. Because what you trained was completion, not correction. Strong students practice differently. They slow down. They review mistakes immediately. They ask, what decision failed here? They don't rush to the next problem until the error is understood. That's how skill is built. Doing more problems feels productive. Fixing mistakes feels uncomfortable. The physics rewards correction, not volume. So if your grades aren't improving, don't study longer, study sharper. More reps won't save you if each rep repeats the same mistake. Here's where students get fooled. Things start to feel familiar, recognizable, comfortable, and that comfort lies. Here's what's actually happening. You're confusing recognition with understanding. You recognize formulas, you recognize diagrams, you recognize work examples. Recognition feels like understanding, but it isn't. Recognition answers this question: have I seen this before? Understanding answers a different one: can I decide what to do next? Most students never test that second question. That is why studying feels good. You reread notes, you watch videos, you follow solutions. Everything looks familiar, but familiarity doesn't require thinking, it requires exposure. On exams, familiarity disappears. The problems phrase differently, the diagrams look new, the numbers don't match your notes. Now recognition fails and nothing replaces it because the decision making was never trained. That is why students say, I understood this yesterday but freeze today. They didn't lose understanding. they never build it. Strong students test understanding differently. They close the notes, they look at a new problem, and they ask, what does this situation ask me to do? If they can't answer that, they don't move on. They diagnose the gap immediately. Understanding isn't feeling comfortable, it's being able to act without guidance. If you can't start without help, you don't understand yet. That's not failure, that is feedback. Stop trusting familiarity. Start testing decisions. That's how real understanding is built. Now, zoom out. Why does physics feel manageable at first and then overwhelming later? Because a weak foundation doesn't fail immediately, they compound. Here's what actually happening. Physics, it's layered. Each topic sits on top of the previous one. When a layer is weak, everything above it becomes unstable. Early in the semester, gaps are small. You can walk around them, you can guess, you can follow examples, so it feels fine. But those gaps don't disappear, they compound. Vectors not solid, forces feel harder. Free body diagrams shaky, Newton's laws feel confusing. Algebra is slow, everything feels rushed. The problem isn't the new topic, it's the old one you never fixed. This is why studying more doesn't help. You keep pushing forward, but the foundation is cracked. More content on top doesn't make it stronger. Strong students catch this early. They don't ask, how do I get through this chapter? They ask, what skill is breaking down? They go backward when needed. They repair before they advance. Physics doesn't punish you immediately for weak foundation. It waits. Then it collects everything at once. That's why the semester feels heavier over time. So if physics feels harder every week, stop blaming workload. Stop blaming pace. You're not overwhelmed. You're carrying unsolved gaps. Fix the layer that broke and the weight comes off. So everything you just saw is not 5 separate problems. It's one system failure. You're studying physics like information instead of training it like a skill. Exams don't punish you. They reveal how you train. And once you change that training, the exam experience changes with it. So let's break it together. 1, you freeze because you skip setup. 2, understanding collapses without performance training. 3, more problems fail without correction. 4, familiarity is mistaken for understanding. And 5, gaps compound until exam expose everything. These 5 breakdowns explain almost every physics exam failure I see. Physics doesn't need to feel unpredictable, and exams don't need to feel like traps. You don't need to be smarter, you just need a better system. Train the basics, build your foundation, and let consistency become your advantage. And if you need more help, the dojo is ready when you are. I'll see you inside.